Assalamualaikum. My name is Nurul Emi Wadina binti Rosli. My metric number is BEEE2364. Going to make introductions of our studies. Previously, most elevators had to be operated by a control machine rooms. But nowadays, some of the elevators do not require a machine rooms as they have inherited a safety system already. Elevator cap is lifted smoothly by the pistons. For a smooth fall, electrical valves control the discharge of the oil. Most contemporary elevators are pushed by electric motor via a system wires and sheath with the assistance of counterweight, which is pulleys. Next, hydraulic elevators use less energy while waiting and almost no power uses while lowering the cap. Hydraulic elevators are those that propel by a pistons that move within a cylinder. Therefore, in low use and low rest application, hydraulic elevators can use less energy than traction elevators. Because of these benefits, hydraulic elevators is more consistent with the requirements of comfortable rides compared to the others of elevators. There are two applications of plans selected in this study. The first one is speed control with PID controller, and the other one is self-turning fusee with PID controller. Control motor with PID controllers is intended to guarantee that the robot motor turns at the expected rate even when there is interference from the environment. It effectively enables you to provide motor speed commands rather than merely motor power directive. In this slide, this is examples of PID motor speed control systems block diagrams. Next application use is self-tuning fusee. The self-tuning fusee is a combination of the classical PID and fusee controller. Several writers has examined various topologies of fusee controllers for linear and non-linear system. George and Hugh presented rule decoupling and one-input rule structures, which allow more flexibility and better functional features than typical fusee PID structures. Objective of this study is to compare the performance of speed control PID controllers and self-tuning fusee to control the speed of hydraulic elevators.
Right now, I will explain about state of the art. The hydraulic elevator is designed with traction, elevator safety measures, and an overflow valve to prevent system pressure from becoming too high during upward travel. In the event of a power outage, the emergency manual valve can drop the automobile to the nearest floor. When the hydraulic system pipeline rupture stalls, the pipeline rupture valve can cut off the oil automatically. When the temperature of the oil in the fuel tank exceeds a particular level, the oil temperature protection system sends a signal to suspend the elevators, which can be restarted after the temperature reduces. Alright, so I'll explain about transfer function method. As you can see, this is an equation that we use in this project. So after that, the second equation are the plan equation, which is we use the matrix method so that we can apply more equations if we use this method. So we move to the advantages if we use the hydraulic elevator. First, the hydraulic elevator has low requirements on the civil structure. It does not require a machine room, only a load bearing wall, and has low requirements on the top level. Second is high security. And lastly is disadvantages if you use the hydraulic elevator. So the first is there is a certain motor noise, and lastly is high installation and debugging requirement. So next, I will pass to the next person.
Assalamualaikum and very good morning. My name is Nurdina Sofia binti Yusuf from BEET22. For this topic, I will explain more about methodology in chapter 3. Hydraulic elevator is the result of electromechanical hydraulic integration, which use a hydraulic power source to propel hydraulic oil into oil cylinder. Plunger is used for linear motion, while the wire rope is used to move the capsule directly or indirectly. As you can see, this is the fundamental construction of the elevator system. We have 8 systems in this project. The first one is guidance system, second is door system, bearing and lifting system, electric control system, hydraulic system, safety protection system, pumping station system, and the last one is vehicle. The calculation in our equation, the first one we use K. K is stand for preparation coefficient of synchronous speed and control voltage, while MJ is total moment of inertia of motor shaft. The third one is K. K is stiffness of steel wire. 4 is C. C is the damping coefficient of steel wire. Next is ML, which total quality of elevator, car and load. VP equal to flow of hydraulic pump or motor. 7 MC. MC is comprehensive quality of hydraulic cylinder piston rod. AC for effective area of rod side of hydraulic cylinder, and EC is for effective bulk elastic modulus of hydraulic fluid, and the last one is VO, which initial oil volume of hydraulic pump or motor to chamber. Okay, for the next part, this is the hardware driving part of the hydraulic elevator system and also the equation. The first one is converter motor model. The second one is hydraulic system model. The last one is mechanical lifting model. First equation, which is converter motor model. The transfer function of converter motor model is established through the equilibrium relationship of force and moment as stated by formula. This is the first equation. One is a converter motor model. We use the formula equation from N in the bracket S over UC in the bracket S, and we got 4.71 while S is K1, and over UC we got JM times 2 pi over 60S plus 4.71. The second equation is the transfer function of the hydraulic system model is obtained in. This is the second equation. For the equation in the part B, which is hydraulic system model, we use the equation from VL in the bracket S over VC in the bracket S. VL we got 2 and S we got CS plus K over VC is ML as power of 2 plus CS plus K. Is mechanical lifting model. The transfer function is represented in the following way. This is the third equation. For all the equation, by manipulating formula 1, 2, and 3, the open loop transfer function of system is shown as obtained in 4. This is the equation for part 4 in our project. Last equation where CO is 4.71, K2, K1, C1 is JM times 2 pi over 60S, and C2 is 4.71. Okay, from the previous value, we calculate in this equation.
Let's see the picture. The first picture shows to us about display the block diagram for the simulation, and the second picture is show about display a PID controller model. A PID controller fundamental operation is to read a sensor, calculate the proportional, integral and derivative response, and then add the three components to determine the desired actuator output. PID and self-tuning fuzzy PID controllers are used to simulate and explore the hydraulic elevator system model. Error curve, trace curve and step response curve are demonstrated in next slide. Let's see the next slide, which is about step response curve with a fuzzy PID controller that is self-tuning. The self-tuning fuzzy PID controller perform better than the standard PID controller with a quicker setting time and less overshoot. Next slide is about PID controller used to trace the curve and trace curve with fuzzy PID controller that self-tune. This graph shows to us how to tracking performance of the fuzzy PID controller and the traditional PID controller respectively. The outcome demonstrates that the latter achieve a steady state more quickly than the former. Other than that, in the next slide it shows about an error curve with a PID controller and an error curve with a self-tuning fuzzy PID controller. The oscillation amplitude of the error curve of the self-tuning fuzzy PID controller is less than that of the PID controller. Next, let's see the elevator speed. Celerity and comfort are important qualities that an elevator should have. According to relevant regulation, its acceleration should be no more than 1.5 ms and its jerk should be no more than 1.3 ms to ensure consistent performance during the startup and brake process. And the last graph shown to us about elevator ideal speed response curve with PID controller and self-tuning fuzzy PID controller. The PID controller and the self-tuning fuzzy PID controller achieve a good tracking response. The fuzzy PID controller outperform the conventional PID controller. That's all from me. Thank you.
Hello, I'm Dini Haikal bin Shamuddin. I'm gonna present about the conclusion. In order to obtain accurate speed tracking, two distinct controllers are presented in this work. The traditional PID controller is the initial controller, while the second controller is a self-tuning fuzzy PID controller, whose parameters are continuously adaptively updated in response to errors and changes rather than being constant. Next, the speed controlled by proposed fuzzy PID has better characteristic and good dynamic behavior than PID, which less response time, smaller overshoot, and less steady state error. In fuzzy controllers, simple rules are designed, while in the fuzzy-based PID controller, multi-rules can be designed for all three controllers, as proportional, integral, and derivative, and it shows gains to make response faster. This shows that the proposed fuzzy PID performs better than the standard PID controller, according to the results. Thank you. That's all from me.